Hello everybody, this is Boost Knowledge. Today we're going to make another video about chemistry, and it's about bonding in atoms. So, we've probably learned about many types of atoms. We learned about compounds last lesson, how atoms really exist, but how do atoms fuse together? So everybody knows H2O or CO2. So for example, how do the hydrogen, oxygen, and carbon atoms interact and bond with each other? As you know, there are like 10,000 or even millions of different bonds between atoms. So how do they work? Well, today we're going to tell you about the three main types of bonding: ionic, covalent, and metallic bonding. So here we have the periodic table of elements, or a display showing all the elements created by Dmitry Mendeleev. We will go through the periodic table in another separate lesson. As you can see, these are the elements, e.g. hydrogen, and this is the atomic number, meaning the number of protons, maybe not electrons, because the electron can change if it's an ion. That's the atomic number. We don't have the mass number here because it's very we currently do not need a mass number in these in the content we're going to go through today. We're going back to the periodic table later. So now we're going to talk about the ionic bonding first. I believe in the last lesson you've learned what ions are. Like, it is a positive or negatively charged atom, so it can gain or lose electrons, and its main goal is to one, maintain a full shell, like in Na+. This is Na+. So in the center we draw a sodium atom. This is the first two electrons in the electronic configuration. Sorry, the circle isn't very good. That is the second circle. And Na, it actually has 11 electrons. So we would probably need to draw another, but because it is a plus, this means that it has one less electron. So we don't need to draw the outer shell. And this literally means that sodium has a full shell. However, the electron could just go nowhere, but it probably has to go somewhere. In this case, it bonds. So, as you can see, this is a sodium atom, and it bonds with another atom. But which atom? As you can see, let me change the color of my pen. Wait a sec. This is sodium. Sorry, this is not sodium. This is sodium. Sorry, guys. This is Na, that's sodium. And we want to bond with a atom that can make a full shell, because there's no point in bonding with an atom that can make a full shell. And you can see sodium has 11, and if we do the math, the outer shell must have 2, 10, 18, 20, or 30 electrons. That's very important. Well, if it reaches 20, it can do fluorine. If it reaches 30, it can do chlorine. And we haven't learned anything beyond 30, so Na can actually bond with fluorine and chlorine. If you use other atoms such as hydrogen, lithium, potassium, rubidium, etc., you will see that the group 1A elements often bond with the chlorine elements, which is the group 7A elements. This is a phenomenon where the atoms are bonded to make a very close structure with both the full shells. Okay, back to ionic bonding. So how do you make an NaCl? So if I draw a Cl, chlorine atom, and it's probably Cl minus because it's Na plus Cl minus, it will be like this. So bear with me. We do chlorine in the middle. We do 2 electrons, 8 electrons, and on the outside 8 electrons, because it should have 7. Because bear in mind, chlorine has 17 electrons, but because it's a CO minus, you have to add another electron. So you can see these two have a total of 30 electrons, Na plus and CO minus. They both have 4 shells, they're satisfied. Well, let's just bond them together. But how do we do that? Because if we literally take away the wait, I do this. If I literally take away the atoms like this is an electron, okay? Because oops. Sorry about that. Because as you can see, sodium usually have this electron. It has an outer shell. Let me draw the shell for it. Like this. Done. But, well, this electron has to go to chlorine, and chlorine wants an electron. So, boom, the shell disappears. Sorry, I forgot. Wrong button. This electron, boom, goes to chlorine. Boom, shrinks. And now it's an electron chlorine. And they like Cl, so boom, they bond together. Well, this is how GCSE teaches them. And this is not 100% true, but we will not cover that in this lesson. They're literally too much for us to do. So a literal drawing would have the Na and Cl together. What about another example, you might ask? Well, about something about like HF, hydrogen and fluorine. As you can see, hydrogen has the atomic number of 1, fluorine has an atomic number of 9, so they add together to make 10. This. So, well, it works. So, we can draw a hydrogen atom. Hydrogen, everybody knows how to draw hydrogens. Is damn easy. Actually, I'm doing draw. But what about fluorine? Fluorine has 9 electrons according to the periodic table. So, we're going to just draw 9 electrons. 6 and 7 plus 2 is 9. And this is because hydrogen gives its electron to fluorine. So what is going to happen is hydrogen can have a full shell, but that's not all the case. What's going to happen is our lovely hydrogen, our lovely little hydrogen is going here, is rotating a bit, it's going here, and as you can see, the hydrogen just goes with the fluorine. They're now together. And of course, the electrons, because they're in the shell, they're together, they will probably mostly go to fluorine, because fluorine has more electrical charge than hydrogen, so they will probably all go to fluorine, but hydrogen still has some shells, they're electron orbiting hydrogen, so, well, hydrogen and fluorine, they are together. And because you can see hydrogen gives its electron to fluorine, as a GCSE explanation, well, this is how it works. Another example might be KCl. Potassium chlorine. So potassium has 19 electrons. I'm not going to draw that. I'm just going to draw the outer shell. Chlorine has 17. And I'm only going to draw the outer shell. In GCSE, you don't have to draw it like this. You don't have to draw it like this. You don't even have to draw it like this. You literally only need to draw the outer shell. But if specified, I would suggest you drawing the whole atom. This is the 7th. So let me go through how it works. As revision. The potassium gives its electron to chlorine. Chlorine receives the electron. That's an easy interpretation, as you can see. And it will do good for GCSE. I'm just making them bigger to make it easy to recognize. And this is actually the dot and cross diagram. This is good. This is a bit messy. Draw it like this. Draw it like the 2 electrons intersect, like this. That's what you need for an exam. Okay, so it's the next type of bonding, covalent bonding. It's covalent bonding. It's spelled with an A. So ionic bonding, just making sure it is actually a metal plus a non-metal. Potassium is a metal, chlorine is a non-metal, of course. But covalent bonding is now when two non-metals react. So, well, this is very good because they actually react differently. So, they don't give electrons, they do complete full shells. They don't give electrons. But what interesting about covalent bonding is what happens is they literally just go together and make the full shell. An example would be O2, N2, or Cl2, for example. These are the diatomic molecules, and we're going to put them on one side, and the other non-diatomic molecules will be on the other side. So, O2, for example, if we go back to the periodic table, oxygen has a atomic number of 8, so that's easy. That makes our job fairly easy. So it's oxygen. And we can just draw the outer shell, which has 4 electrons. And we draw another oxygen. And the two should overlap when you finish your drawing, but I'm just not overlapping it just to explain the process. And for these, when you draw these dot and cross molecules, what you have to see is that you have to literally calculate how much it needs. So oxygen has 4 on the outer shell, it needs 8, so it must plus 4. And the other has 4. So what happens is the two oxygens share all, I literally mean it, all their electrons in this process. Every single one. So, well, let's make an animation. Boom. That's it. That's the oxygens. I mean, it still looks a bit messy, but, well, that's that. And that's the same for nitrogen or chlorine. For example, for nitrogen, when it has 5 on the outer shell, they only need to share 4 with the other. So, if we just make this nitrogen, this one would have 1 more electron, this one would have 1 more electron. Because nitrogen is 7, oxygen is 8, nitrogen is 7, wait a oops. Sorry guys. Nitrogen is 7, oxygen is 8, so what will happen is it doesn't have this much. So sorry, it's not N2, it's F2. Sorry, sorry everybody. If it was fluorine, it would be have an outer electron. And for final example, Cl2, chlorine, what happens with chlorine is that because fluorine and chlorine are in the same group in the periodic table, what you will see is that they have the same number of outer shell electrons, so it's literally the same. You just change the F to be chlorine. So this thing is the fuss about how many electrons you share, like that. And now let's move on to the other type of covalent bonding, non-diatomic. So like NH3, for example. NH3 is literally a nitrogen plus 3 hydrogens, so we're just going to do that. A nitrogen inside. And put 3 hydrogens. These 3 electrons are separated because you'll know why later, because here comes 1 hydrogen, here comes number 2 hydrogen, Here comes number 3 hydrogen. Yeah, so that's it. That's NH3 done, and you get a mark for a double cross diagram. That's that. We've done covalent bonding. A point what I like to add is about O2. So it's O2. People ask, why can't you say represent oxygen as O? But that is dead wrong. Because an oxygen atom by itself, as I mentioned in the last lesson, does not have a full shell. And if atoms don't have a full shell, they go crazy. They must have a full shell. So what happens with oxygen is it must be O2. 2 atoms with covalent bonds. And what about O3? Well, O3, if they are together in the correct option, it can exist, but it doesn't exist very commonly. So, what about, you might ask, CO? CO, CO2, and CO3 have 3 different ways of bonding together. That's why they all can exist at the same time. Well, I hope you've enjoyed this video. Part 2 is coming in 3 seconds, and we'll see you next time.